Welcome to the 6th lesson in an introduction to Kubernetes. Now, I'm sure if you watched the last lesson, which you should, it was on pods, and you got a good understanding of what pods are, and what that pods aren't necessarily the entire answer to the Kubernetes deployment. So we did just spend a lot of time with pods, but again, as I've stated in the last lesson, we don't deal with pods most of the time. We deal with other constructs in Kubernetes. So what do we use? Well, we use deployments. When thinking about deployments, think of Kubernetes objects that can control and manage other Kubernetes objects and layer functionality. Almost like the Unix principle of do one thing and do it well. Each of these things are able to focus on one thing. So, in the last lesson, we learned that a pod's focus is on containers, the resources and general running of a logical set of processes, and ensuring that those processes have access to the things they'd like. So it makes sense that there would be something else that is worried about running pods. Let's start this lesson out first by creating a deployment and learning from using that deployment. So we're going to jump into the command line and use kubectl create deployment nginx --image equals nginx --dry run equals client -o YAML, and output this to a file called nginx-deployment.yaml. This, like the run command for pods, will create a deployment for you. Now all you have to do is run kubectl apply and with a -f to apply the file. Or if you did not want the local file, you could have left the dry run equals client and the piping to a file part, and it would have already created it directly on your Kubernetes cluster. Now, if you applied the file, you have this deployment running on your cluster. Let's check it out. We can use Cubectl Git Deployments just like we did with pods to list all of our deployments in the default namespace, of which we only have a single deployment as of yet. Let's get that deployment. Kubectl Git Deployment nginx will return the new deployment and give just a little bit of information about it. Now, this is not a lot of information, and I hardly ever run kubectl command without at least using the -o wide option. But there are a lot of output options, from wide to JSON, YAML, and JSON path, giving you all of the options you need for obtaining just about any information you want, or all of it, or none of it. If you noticed, the replicas was set to 1. Alright, so we did get deployments, and we saw we had a deployment with a replica of 1. We've only applied a deployment. That's the only manifest that we've applied. Let's see if there's anything else running. Let's go ahead and run kubectl git pods. Look right there. You have an nginx pod running. You'll notice the name has a unique name to it. Okay, so in the manifest, we can see and verify that we had a replica of 1, and we have 1 pod running. So while we only created a deployment, we now have a pod running. Now, we probably want 3 pods running just in case one crashes or something like that. So let's fix that. We can either update the manifest and reapply that manifest, or we can just run kubectl scale --replicas equals 3, the deployment nginx. And now, if you run your git pods command, you can see more pods are getting created in the default namespace. And we did not have to create or manage any of the pods by hand. In fact, let's put this to the test. We're going to simulate a failure. We're going to remove a pod that is managed by the deployment. Kubectl delete pod, and the pod name is all you have to run. So let's use kubectl git pods first to find the name, because you notice that they have unique names from the deployment, and then go ahead and delete it. So now we should see 2 pods running, right? Wait a minute. The deployment has already fixed the issue, and we now have 3 pods running still. It's super useful, and the deployment is the de facto way to deploy something in Kubernetes. Now, We scale this by using its name and its type, deployment, and name. So in our case, it was deployment and Nginx. But you can also scale it by using its file. On top of this, scale can be used on pretty much anything that has a replication factor. So think replication controllers or replica sets. Let's take a quick look over the YAML file that was used to create this. As you can see, the number of replicas here in the YAML, that's where we would want to update it and then just reapply the YAML if we wanted to update it in our manifest file. Super cool. But let's move on to some other things in this manifest file. You'll notice that this has 2 spec fields, not just one. The first spec is the spec for the deployment, and the second nested one is the spec for the pod. You could add another container here or update this to a new version of Nginx or whatever you want. This is how you define the pod inside of the deployment spec. You will also see some things around strategy, labels, and some other things. But these, while very important, are also much more advanced, and we'll cover them at a later time in this class. Other than label, we're going to cover label in this lesson. Every object in Kubernetes can be labeled. That being said, lots of things use these labels, and we're going to explore one way those are used right now. Know how I said that deployments did not do it alone, that they had some help somewhere? This is where replica sets step in. Let's see them. You can run Cubectl Git replica sets, or you could just use rs instead of replica sets, and see the replica sets being used for our Nginx. Now, if we had a lot of deployments and a lot of replica sets, this could be really hard to know which one is what, and this is where labels come in. You can use Cubectl Git replica sets -l app equals Nginx. This is just one of the ways that labels can be super helpful. But just trust me, their use is even greater than this, and you're going to see that in the future when it comes to scheduling and taints and tolerations. Okay, so I don't want to get too in-depth about replica sets, but let's just cover it at a really high level. You can use replica sets by themselves without deployments if you want, but when using deployment, it owns the replica set and is the main way of using replica sets. Most people don't use them directly. Deployments use replica sets to orchestrate pod creation, deletion, and update. It's really quite cool, and we will cover replica sets more in depth later on. So we could say at this point, deployments use replica sets to manage pods, and pods use containers to run your processes. Deployments are the main way to deploy your app, and anything that doesn't use a deployment would be considered a very advanced solution. Now, this is awesome, as now we don't only know how deployments work at kind of a high level, but we also know how they work and how they run containers in the end. In the future, we will understand more of why each of these in the deployment stacks is there. But for the most part, each one is worried about a single issue and does that one thing well. Pods worry about containers, replica sets worry about pods, and deployments worry about replica sets. Deployments bring it all together with a declarative update for the pods and replica sets, enabling you to describe a desired state in a manifest. Now, there are a lot more things to learn here, but we're going to move on so that we can understand more about the ecosystem around deployments to help you manage the deployment of your app. In our next lesson, we're going to dig into the Kubectl command line tool to just understand it a little bit better, how to manipulate it, how to use it, and how to use kubeconfig files so that you're going to be able to leverage not only Kubectl better, but your Kubernetes cluster as well.